7 in the Kelvin Skeete CXC IT section 2, performing calculations in problem solving algorithm. Calculations are used to process data. Data that is to be processed could involve performing calculations. Calculations can be done by using mathematical operators for addition, subtraction, multiplication, or division. For example, the plus sign is used for addition, the minus sign for subtraction, the asterisk for multiplication, and the forward slash is for division. When calculations are to be performed, numeric variables or numeric constants must be used. The results of the calculation must be stored into a variable for future use, such that printing can take place. The syntax for a calculation instruction is variable name. Where you have the equal sign right there, please change the equal sign to an arrow pointing to the left as indicated there. Change the equal sign to an arrow. Change the equal sign to an arrow pointing to the left. That arrow is called the assignment operator. Yes? Now, for example, amount due is assignment arrow, which means assign the value of price times quantity. So for me to get the amount due, the value of the price is, for example, $50 and the quantity is $10. So therefore, the amount due will be the $50 multiplied by how much? $10, 10 quantity, which gives me how much as the amount due? $500. Inches is assigned the value of feet times 12. So if I put in 3 feet and I want to know how many inches are in 3 feet, then I multiply the feet by the 12 and I store the answers as inches. Sum is assigned the value of the first number plus the second number. So the first number is 6, the second number is 11. You add them together, what's the value of sum I get over here? 11. 6 plus 5 is 11. Good. Now, very important for you to understand is that following on page 90 in the Kelvin Skeete textbook, the results of a calculation is stored in the variable to the left of the, change that equal sign to the assignment arrow. This variable is therefore assigned the results of the calculation. Any statement that assigns, I'm going to use the word gives. Take out the word assign here and use the word gives. Any statement that gives a value to a variable is called an assignment statement. So the assignment statement gives a value to a variable. So for you to get amount due is the price multiplied by the quantity. When you find an answer, put the results in the variable called amount due. So they are saying to you, the results of the calculation is stored in a variable to the left of the assignment operator. You need to understand that. The results of the calculation is stored in the left of the assignment operator. So you have the arrow right here. So the arrow right here. So this calculation right here is stored to the left right here in the variable called amount due. Yes? Can you get your what? What books? I don't have your writing books. Now, the value being assigned could be a constant or a variable or a calculation. Right? And I'll say that again. The value being assigned could be constant or variable or calculation. The value the value being assigned could be a constant or a variable or a calculation. Please watch me. Pi is a constant. Do you agree? Why is pi a constant? The value of the data item does not change. So pi is assigned the value of what? 3.14. No, you can't write fractions. So you must extract the fraction as a good. Now listen again. Listen. Listen. Listen and pay attention. Pi is assigned the value of 3.14. That's a constant being given a variable. It says to you that the value being assigned could be a constant or a variable. So A is assigned the value of B. B is a variable. Yes? Yes? So if A is 1, if A is assigned the value of 1 and B is assigned the value of 2, and if I say that A is equal to B, what's the new value of A? 2. Because A has a value of 1, B has a value of 2. If I say that A is assigned the value of B, that means the value of B is being passed into the variable A. So you are assigning a value to a variable. So what we are seeing therefore is, if I say to you right here that A is assigned the value of 1, B is assigned the value of 2, and I said to you that B is assigned the value, A is assigned the value of B. No. Listen to me. Listen. Regina, listen. Look in the book and listen. So slow it down, Elita. A is assigned the value of 1. What's the value of A?
1.
B is assigned the value of 2. What's the value of B?
2.
If I say to you that A is assigned the value of B, what's the value of A now? 2. Because B is assigned the value to A. So therefore A will get a new value of 2. So the value of A was what before?
1.
So when you say that A is assigned the value of B, what you are doing is overwriting the value in the variable before. You're going to get on to a question in CXC that says to you, you must interchange the value of two variables. They give you A and B. And they ask you to make the value of A going B, the value of B going A. Alright. If I want you to interchange the values of the variable, I could say to you, interchange the values of the variables A and B and print results of A and B. You found the other book? That's 9 now. Alright, thank you. Okay. Anybody in the book over here? No, sir, thanks. Alright. So, as you can see right here, we're going to interchange the values of two variables A and B. Okay. So, if the value of A is something and the value of B is something, I want to switch them around. Put A in B and put B in A. So, what would I say right here? First of all, A is a value of values already. So, let's say A is assigned the value of 5 and B is assigned the value of 4. I want to make A have 4 and B have 5.
A is assigned the value of B and B is assigned the value of A.
But if I do that straight away like that, I'm going to erase a value. So what do I need to put in then? I need an empty variable to take in the results. If you have a glass with orange juice and one with water, right? If you have a glass with orange juice and one with water, you want to exchange them. Do you throw them into each other? You get the next glass, and you throw the orange juice from one glass into the third glass, so that this glass becomes empty. Then you throw the water from this glass into this glass, so the water glass is empty. Then you go for the third glass, throw the orange juice from this glass into the water glass. So you need that empty variable. So we say that C therefore is a standard value of what? A. So pass Mr. Mackenzie. Mr. Mackenzie, you're working on my nerves. And when I say you're working on my nerves, then take this off me, please, Danny. When I say you're working on my nerves, it could be a parent calling back. When I say you're working on my nerves, you're working on my nerves. You don't pay attention in class when I'm teaching. You're working on my nerves. Who is that? A parent? Whose parent is on the phone? Who? Janelle's Miller. She's not at class right now. Mommy, I'm teaching. Janelle went home, mommy. Janelle left until she wasn't feeling well. She told her student to tell me. Okay, 5:30. All right. What am I in the case? Oh. Okay. I was leaving to put him in the staff room drawer after I finish then. Okay. All right. Now pay attention, guys. Pay attention. I'm Mr. Wilson. Now it says interchange the values of the variables A and B. That means whatever is in B must go in A. Whatever is in A must go in B. A is assigned the value of 5. B is assigned the value of 4. So if you want to take the value of A and put it in the B, you need a third variable to store that data temporarily. So that A is assigned the value to C. What's the value of C right here then? 5. So the value of A now has lost data. So therefore, we now put the value of what? B into A. What's the value of B? 4. It's now going to the variable A. So A is now 4. What is in B now? Nothing. So what do you do now is transfer what? C is assigned the value of B. Because C is 4, are you going to pass the value of C? You see? A is 5. A is 5 right here. B is 4. Yes? So when you say A right here, the value of 5 is being passed into the variable C. When you do that, what happens to the value of A? It becomes empty. Right? So now that A is empty, we can transfer the value of B into the variable A. So A what's empty now has in how much now? 4. So B no longer has a value inside of it. Then now we transfer the value of in C to the variable B. And then what do we say right here now? Print A and print B. So A now would have how much inside of it? And B will have how much inside of it? And that is an actual CXC question. No. Because you have to read in the variables A and B first. Give them data. And what it said, transfer the value of A into C, transfer the value of B into A because A is now empty, and then transfer the value of C into B. So what happened now to C? Empty. So in storage, C is therefore called a temporary storage area which only exists while the program needs it. Yes?
Sir, so when we just ask to interchange the values of the variables a and b, you can put in any.
No, no, because of the need for an explanation, I had to put in numbers for you to explain it.
Oh, so they
But
just
in
set
the
up
same
and
sequence, they didn't give numbers.
sir, how would they set it up?
Exactly as is. Write a program teach to the value of two variables a and b. So you have to assume the values are already read in already. So you read a, read b. So you could say read a, read b instead of putting a equal 4 and b equal 5.
And then you just interchange it yourself.
So what I did was to make a and b a what? What did I do? I made them a what? A constant. And then I used an assignment statement to change the value of the constant. Because an assignment statement can change the value of a constant. The book tells you an assignment statement gives a value to a variable. The book tells you that. But in reality, when you get to advanced programming and looping, you can change the value of a constant by using an assignment statement. Not very popular, but it can be done. Let's go again. So this is clear.
Yes, sir.
All right?
One question, sir.
Yes?
So you use different C or what?
No, it's the same C because the C is only a temporary storage location. I only brought in C just to store data temporarily. In programming, in it's called it is acting. No, it's not a buffer. It's acting as a buffer. A buffer, a buffer is a temporary storage area from which data can be accessed. Make a note of that, please. You learn that term in memory storage. Buffer. A buffer is a temporary storage area from which data can be accessed.
Repeat them. A temporary storage area is there.
From which data can be accessed. Assignment operator. Kayla, what was your question, Kayla? The C was a temporary storage location. What is it saying right there? C is assigned the value of A is assigned the value of B, and then B is assigned the value of C. The Vasca is asking, how would you do it? The Vasca is asking, how would you do this question using read statement? So all it say right here was what? Read A, B. And all it says C is assigned the value of A is assigned the value of B, and B is assigned the value of C. Print A, B, N. So there's one. So this one is where we use the read statement taking the input. So you'll put in two numbers here in the computer and input them. You could say print, enter two numbers, and then after your prompt to read it, exchange the value of A to the variable C, the value of B into the variable A, and the value of C to the variable B. Then you print A, print B, and N. write a program, write a pseudocode algorithm to interchange the value of two variables a and b. There we go. All right. So what we end up with is a pseudocode that says read A, comma B, C the sign the value of A the sign the value of B the sign the value of C,
Print A,
print
print
A,
B,
print B,
full stop.
full stop. So what you end up with is a program. I'm trying to do a screenshot. I have to put it in the video. Alright. Now, so right in the book again, grade is assigned the value of A, total is assigned the value of B, A plus B plus C.
In the book,
Each assignment statement must begin with a variable followed by the equal sign. Then either a variable or a constant or calculation.
so that should be the assignment
Take out the equal
operator.
sign
The
and
assignment
put
operator.
assignment operator there.
Where's that number one below?
Number one, where it says each variable.
Yeah, see?
Now, this book was written before 2010. In the new CXC policy document that came out, they asked as of 2010 exam that teachers introduce the students to use of assignment operator. Assignment and equality is not the same thing. In doing a simultaneous equation, we say that 6 plus 5 is equal to 5 plus 6. That's equality. Whatever is on the right hand side is the same as on the left hand side of the equal sign. It's not the same in programming. But what you're doing is passing some calculations from the right hand side to the left hand side variable and store it. Assignment statement give a value to a variable, or it can change the value of a variable or a constant. You might want to make a note in your book. Assignment statement gives a value to a variable, or it can change the value of a variable and constant. The assignment statement gives a value to a variable, or change the value of a variable or a constant. An assignment statement gives a value to a variable, or change the value of a variable or a constant. Okay, moving on. November. All right. Now, let's go again. I will ignore the second option right there because you don't use it. The word store followed by a variable, a constant or a calculation, and the word to. You don't need to do that. It is incorrect to write an assignment statement in the following manner with a calculation to the left hand side of the change equal sign to assignment operator. So when you're writing, you can't place the calculation to the left of the assignment operator. Can't. You can do it in a math class in some situation, but not in programming. The calculation is always to the right hand side, and to the left hand side is where you're storing it as, always. The variable which begins an assignment statement should not be a variable that was read as the input if the input is to be printed. Let me slow that down for you. The variable which begins an assignment statement should not be a variable that was read as input if the input is to be printed. The book is not clear in its expression. All right. Let me just back this up for you very carefully. Good afternoon. Shani, Maria? Daddy talking to Shani. Hold on. All right, guys. 5:30 is picking you up. All right. Let me slow this down for you. The variable which begins an assignment statement should not be a variable that was read as the input. So, if you want to use a variable sum to add two numbers, you can't say read sum, comma, num1, num2. Then go say sum is assign the value of num1 plus num2. Then you say print sum, then end. What they're saying to you now, listen again. Pay attention, Daniel. Pay attention. The variable which begins an assignment statement, the variable, which is sum right here, should not be a variable that was read as the input. So you can't have sum here with this num1, num2 if the input is to be printed. So this can't be here. That sum can't be there. Because again it says the variable which begins an assignment statement with sum in this case should not be a variable that was read as an input. It can't. Cannot. Alright. That's the point they're making. So what you'd write is read sum, comma, num1, comma, num2. Sum is assigned the value of num1 plus num2. Print sum end. We're saying that on the read statement, you cannot read a value for sum since you're doing the calculation for sum using the assignment statement. That is a little bit tricky in the book. It does not say it clearly. But because sum is the input, as the Pascal is explaining, because sum is going to be used in an assignment statement, then you can't read in the value of sum up here in the read statement. You can't. Because sum gets a value because of the calculation of num1 plus num2. Okay. Variables used in a formula for calculating must be variables that were executed prior to the calculation of the instructions. Variables used in a formula for calculating must be variables that were used in the executed statement prior to the calculation instruction. In other words, what we are saying, we couldn't say up here print sum, then say sum is assigned the value of num1 plus num2, then end. So if I say to you, read num1 comma num2, print sum, then on line 3 I said sum is assigned the value of num1 plus num2, then end. That can't work because it says the variable used in a formula for calculating, which is sum, which is line 3 in this case, the variable used in the formula for calculating must be variables that were executed in statements first. So if I want to print the sum, I have to move the sum, the print sum statement, and put it after where sum is assigned the value of num1 plus num2. Because I would have calculated the value of sum already, and then I can print it. But I can't print sum if I have not yet done the calculation to get sum as yet. You can't. So the book says variables used in formulas for calculating must be variables that were used in the executed statement prior to the calculation being done. So if I said A is assigned the value of 1, B is assigned the value of 2, and C is assigned the value of A plus B, what's the value of C going to be? Plus 3, because 2 plus 1, 1 plus 2 is 3. But if I said on the first line that C is assigned the value of A plus B, then that A is assigned the value of 1, B is assigned the value of 2, and I say print C, then end. Something wrong with that order. Because I can't print a variable before I've actually calculated the value of the variable first. That's a rule. Variables used in a formula for calculating must be variables that were used in executed statements prior to the execution. It's in the book, page 19. Alright? So we are saying right here that variables used in a formula for calculating must be variables that were used in executed statements prior to the calculation taking place. So you can't say print sum and then go and find sum as num1 plus num2 afterwards. You must do the calculation first and then you print the variables afterwards, sum. Yes? Now let's go to simple arithmetic. Writing statements to do arithmetic. It's in the book, please. She embarrassing me. Bring a flashlight, come next time. Now, writing statements to do arithmetic calculation isn't difficult. The hardest thing is to remember when to do what. The table below should help you to work out this. If you hear the word sum and total, then you need to add. So sum is assigned the value of num1 plus num2. Difference means to subtract. So difference is assigned the value of num1 minus num2. Product means to what? So therefore, product is assigned the value of num1 times num2. And the word quotient means to what? Which is num1 divided by num2. Very good. So therefore should be a num2 here then. Daniel, one of the things I want to get into you people's head, and it's the hardest thing to get into the head. Apart from Danny, who normally do work, Kayla, Jerome, Graves, Moulton start, Chanel start, Regina, give and take that we've been having rains for the last 3 days because Shanika actually did her homework this week. You see, I keep on preaching to some of you, but you're not listening to me. You're not listening to me. And that is why you start to add a lot of stress onto me. I shouldn't be worrying about this group. But there's too much stress going on because people are not doing their assignment. And what this is causing, it is causing the class to progress at a quick pace. When I said to you last week, I won't give any homework last week, I didn't give any homework really. I said to you, read chapter 7 in the textbook. It might make sense, it might not make sense. You just read. And when you read it, try and practice the questions in the book to see if you're getting it. When you come to class, I'd work it out with you and clear up the confusion in your head. You see, sometimes as a good teacher, you walk the student to read ahead of you, to go learn, to just learn something. And if it don't make sense, when you come to class, at least when you read the book, and when we go through it, it makes a little bit more sense to you. I said to the grade 11th, and I can say to you, if you look at how you learn at grade 10 level, it's not the same way you are taught at the fast track class. It's not the same way. It's two different teaching. At grade 10, I am teaching you to learn things. At grade 11, I'm coaching you to get ready for an exam. Coaching means to increase your understanding. I don't normally do homework in class. But when it comes to grade 11, I have to go through the homework to ensure if there's anything that you misunderstood in the homework, let's fix it before we move on to the next step. If you learn a bad concept in the earlier stage, it will affect you in the later stage. And that is why everything we're doing is a jigsaw puzzle. Every day you come, you learn something new else in the program problem solving. I'm taking my time to teaching you. Programming and problem solving is the worst performing area in CXC IT. 2 in every 10 students get an A in the profile on the exam paper. 2 in every 10. In Mona High School, we get like 1 person in every 20 get an A in programming and problem solving. 1 in every 20. I'm going to put that 15. So we don't get a lot of A's in the programming. Now, when you don't do well in the programming part of the exam, it pulls down your entire CXC grade. I just want you to understand those complications. Just do what I say. I give homework, try something, just try it. If you do pure garbage, nothing wrong with that. The important thing is you try. And you try it yourself. And when you make mistake and get confused, you stop because you're getting confused. Take a break, go back and try it again. Until you see if you can get it. Until you don't get it, you come to class and you work it out in class. We're having learning problems in this group because a lot of you are going to get into some hot water with me when it comes to sign the slips or recommendation, because you don't listen, you don't do assignments, and you're adding to my stress level. You have been warned. I've been saying it several times coming along. I sent several face-to email threads to people about homework. You know those emails that came out? Start beside your name. Only can't stand them because you swear you're hurting me. I'm not the one paying 5,000 MASH for one CXC subject. But when your parents pay 5,000 MASH to do one CXC subject, they have to pay extra class fees every month. You come to weekend classes every month, and they invest all of this money in you. They want to see result. And when you fail the exam, the first thing they normally say is the teacher never teach properly in the class. And they not blame you as yet in the preparation. But that is why me always love send email to parents. Because when una fail, una can't say them never did know what going on. And I've asked you to invite your parents to come and speak with me about your performance, and up to now, only a handful of parents have come to me. And on all the invoices that I sent out, I asked parents to come and see me the first 2 weeks in October if they have not seen me as yet. So when I don't recommend you for CXC, you know why. Parents and teachers have a conversation about the child. Because when the pitney fail, is the teacher alone left standing. Is the teacher get all the blame. Not the child who wasn't doing their homework, not paying attention in class, fooling around in class. It's not the child get the blame. It is the teacher that gets the blame at all times. A common programming problem is to calculate a person's percentage score in a test or an exam if you are given his or her score as well as the maximum mark. To calculate the percentage, divide the total or the maximum and then multiply it by 100. For instance, if the maximum mark in the test is 20, the percentage score is the score divided by 20 multiplied by 100. Assignment operator is needed here. Brackets are needed here in math class. Score divided by 20 must be bracketed. Do you agree? Yes. And then where you have, I multiply by 100. So if you get 18 out of 20, then it's 18 divided by 20 multiplied by 100. That gives you your actual percentage score. They have to give it a maximum score. Yeah, but I'm saying they have to. If they don't know, you have to make a what? You have to make a what? A word. I told you. I said to you, if you are not given some information, you have to make an assumption. When I was teaching a problem statement, I said to you, write a program to calculate the area of a triangle. I said to that statement is ambiguous. If you said, write the program to calculate the area of a right angle triangle, it's no different, because you now assume the triangle is right angle, where the formula is half base times height. But not all triangles use the same formula for right angle triangle, half base times height. So if you make an assumption in anything you do in computing, your boss will ask you, why did you do it this way? Boss, I assumed, because I'm not getting information, I have to assume. So if it's all the scores are less than 20, and the highest score is 18, then maybe the maximum mark in test is just 20 mark out of 20. You have to make an assumption. You could mark out of 100. Because unlike everybody will be getting those grades so low. Now, over here now is finding the percentage of a number. Suppose you're asked to calculate the VAT on an item. In this case, you don't have to calculate the percent because you're given the percent of the value added tax as 15%. Instead, you have to find 15% of the item's price. To find a percentage of a number, divide by 100 and multiply by a percentage. Something not sound right there, so. Because in a maths class, you wouldn't divide price by 100 and multiply by 15. What you do is just multiply it by the 15%. So it's a price multiplied by 15%, you get the tax amount alone. Correct? So you would need to say divide by 100 and then multiply it. No. Remember in database when you're doing update queries, I said to you that you're not to use the percentage sign in your calculation. The reason being, the percent sign carries a special meaning in programming which you'll learn later on. The percentage sign carries a special meaning in programming. Now, what you do instead is express the percentage as a what? A decimal. This is a very important concept. This concept is going to come back to you when you start advanced programming in looping, which is to increase and decrease the value. Writing a statement to increase or decrease a variable is a very easy one to get the hang of it. Look at these examples. Count is assigned the value of count plus 1. Numless is assigned the value of numless minus 5. Let us give this some real world application. Those persons who take JUTC bus in the evening, do me a little experiment this evening. When you go on the bus, look at your bus ticket number. It might be like 124. The person who came in after you, look at their ticket number. What do you see on it? 125. Because the passenger count increased by 1 each time. So every time the driver stops the bus and pick up somebody and catch a ticket, the ticket number goes up by 1 passenger each time. Correct? So even if Kayla and her mother and her sister went on the bus, they print 3 tickets for them. So the number will go up by 1, then by 1, then by 1 again. Correct? If your mother bought a case of soda and put the case of soda in the deep freeze to cool, how many sodas are in the case? 24. Or it could be Sizzler or anything. And when you go in the fridge and take out 1 bottle, how much do you have left? And your brother come and take out 1 bottle. And then the mother come and take out 1 bottle. You're decreasing by the same number each time. I need to introduce to you what is called incrementation and decrementation. Incrementing and decrementing. Right here, incrementation statements are used to increase the value of a variable by the same number upon each successful iteration. It is called a loop. So the incrementation statements are used to increase the value of a variable by the same number upon each successful iteration. What does that mean is that every time the driver stops the bus to pick up somebody, he goes through a procedure to give you a ticket. And when he complete the procedure to get a ticket, the ticket number will always increase by 1. That is an iteration, which is a looping. To increase the value of a variable by the same number upon each successful iteration. Because I'm teaching you from scratch. Remember, all you did was just take what you learned from grade 7 to 9 ITE or grade 8 and 9 ITE, and I'm using everything right now. But I'm teaching the CXC syllabus as if you're a first timer to the class. You realize that? When I started spreadsheet Excel with you, I start from scratch. When I start database, I start from scratch. In fast track program. With the database in grade 9. But you didn't go as far in database. Molten stop fill up Chanel down there. See those girls down there? As the light turn on, so they get excited. Alright, let's hurry up, guys. We're almost out of time. 23 minutes. Incrementation or incrementing. You can say incrementing or incrementation statements. I'll accept either. The other one is decrementation or decrementing. Decrementing or incrementing statements are used to decrease the value of a variable by the same number for each successful iteration, otherwise called a loop. So decrementation or decrementing statements are used to decrease the value of the variable by the same number for each successful iteration. And the word iteration in programming is the same as a loop. And this is a Kisco example, or the case of soda example. 24 cases of 24 sodas are in the fridge. And if you go in the fridge and take out one each time, the number of sodas keep going down by one until they get to 0. So you decrease by the same number. And incrementing statements, you increase by the same number for every successful iteration. You're going to buck up this concept again when you do looping again. Now, the trick is that when you increase or decrease the value of a variable, the variable appears on both sides of the assignment statement. Yeah, because it says right here that count is assigned the value of count plus 1. So the variable appears on both sides of the assignment operator. You realize that? But you are told that the storage location must always be on the right hand side. So both sides of the assignment, not statement, right here, assignment operator. This pen is bleeding. Anybody have, no, bleeding means it's flowing too fluently. Anybody have a reading pen, please? No, if you use red so you can see clearly on the screen. I have to use red. I use the marking. Please remember, I love that's called gel ink pens. They write very nice when I'm marking. They write easy and quick when I'm marking. So if you want to buy me reading pens, please you can buy me the gel ones then. Or Kingston Bookshop has some wedding pens. They have the silver looking thing on the side of it. They're like for $64 for them.
Oh, okay.
So you can buy me wedding pens, please. I can buy red or green. Red or green. Please. No, those the peppermint ones. Them when you write for a long time, your finger right here starts to hurt you because I sink in the finger right here. So I like to get the pen. I can just move it in on the paper easily when I'm marking. I don't have to press on my paper very hard when I'm marking. You want to buy me a pen? You can buy me a gel ink pen, or you can buy not the cheap one, peppermint pen, please. Kevin Henry. Where's Kevin? Kevin? Chambers. You're very quiet today at class. Are you okay? You're having a fever? You're not misbehaving today as you normally do. Kevin, you have the floor. Yes. All right. Now, what we're saying right here is that when you write, when you increase or decrease the value of a variable, no, this one isn't it doesn't. With these, I have to press on it when I'm writing. So I need something that is fluent, like a gel. Yeah. No, once you see when you have to mark long, your finger hurts you right here. Yeah, so that's why I use gelling pen because it move, but it don't dry as quick on the paper. But because you're marking like test papers, you put it down so it dry. But like now, touching it right here, so right now it is still smudging. Now when you increase or decrease the value of a variable, the variable appears on both sides of the assignment operator. Some persons find this confusing. Let's look at this in more details. What's going on in the first example? Assume that count currently has a value of 3. So count is now 3. So right here, the value of count is 3. And one more person called the bus a while ago. So it's going to be 3 plus 1. Give you what? So the new value of count here is what? It means that if we go down to the example at the bottom right here, and you're increasing the value of a variable by a percentage, it's a little bit more trickier. Here's how you would increase the value of a variable by 5%. Price is assigned the value of the price plus the price multiplied by 5%. You have to find 5% of the price, then add this amount to the old price to give you this price over here. So this price is what price? The new price. This is the original price. And this is the 5% of the original price. So we are going to now change these in the book now, where the 5 divided by 100 here should be 0.05, and the assignment operator here. So you now end up with price is assigned the value of price plus open bracket price times 0.05 close bracket. The following example shows the equivalent statements that all increases the variable by 2%. Over here, salary is assigned the value of salary plus salary times what? 0.02. And they do it right here for you already. Or you could multiply salary by what? 1.02. Correct? And will increase by 2%. The following example decreases the variable salary by 2%. Salary is assigned the value of salary minus salary times 0.02. You want the 2%. Salary is assigned the value of salary minus salary times 0.02. The last one, there's a problem with the last one. This colon equal, and I hope you're paying attention. You didn't see that? You say, I say to you sometimes, A good teacher always leave errors in their work. So when they are teaching, they can use the error to bring out a point. The book have errors in it, but it makes it very interesting to use to teach, because out of the errors you can make certain teaching points that will make the children understand the concept better. Now the colon equal right there means the same thing as the assignment operator. It means assign the value of, except it breaches the description of a pseudocode algorithm. A pseudocode algorithm is not written based on any programming language. Colon equal is only used in Pascal programming, the language you'll be studying. You are just doing pseudocode algorithm. So this colon equal here must be changed to arrow, because if you use colon equal, you are violating a rule in pseudocode, because you don't write pseudocode based on any programming language. You write pseudocode and then you learn a programming language like C, Java, Pascal, and you use it then to implement that pseudocode to run in a program. But at this stage, pseudocode algorithm is only a mathematical and English-like expression that is used to express programming logics. So pseudocode is a mathematical statement and an English-like statement that express programming logics. Alright? So I'll stop the recording here.